Now it's time to hear our last visionary talk of ITC, the 58th ITC. And this will come from Advantest. And we're very pleased to have Keith Schaub with us. Keith is the Vice President of Advantest for Applied Research and Technology. He has been very active in the field of semiconductors for 25 years. He's been part of several startups, so he comes with a small company and large company experience. He consulted on RF system architecture for several Fortune 500 companies. Keith has also multiple AI-related patents and papers in NLP and VR for Enhanced Test Engineering Debug, for Smart Auto RF Matching Load Board, Automated Robotics, Smartphone Production Testing, and AI and Machine Learning for Anomalous Defect Classification in this case. I'm sure we'll see some of that in his talk as well. Keith, please. Let's welcome Keith.
Well, so first of all, Yvonne, thanks for the invitation. I'm very glad that he asked if you're enjoying the show before my talk. So the good news is this is the last visionary talk, so you don't have to listen to it anymore. The bad news is this is the last visionary talk, so all the visions have already been done. Several years ago, I was giving a lecture somewhere in Asia, and I was teaching this class, and after an hour into it, I asked if anyone had any questions, and not a single hand went up. So I thought, I'm an amazing teacher. An hour later, same thing. I asked, do we have any questions, and no hands went up. Then I thought, I must be a natural. At lunch, I was very excited to tell this to the organizer, and talking about the class and all the material and how everyone is absorbing the slide set. And she stopped me and she said, Keith, I'm sorry, nobody understands you. We don't speak English. So she saw my deflated look and she threw me a bone. She goes, but we really like the pretty pictures that you draw on the board. Okay, so my name is Keith Schaub, and I'm actually the Vice President of Business Development. Vice President of Applied Research is actually Ira Leventhal, sitting right behind me. But what we do is we develop new and emerging technology, and we integrate that into our services and products. And the reason that we do that is to expand our customer value. So what I'm going to do in the next, I guess, 20 minutes here is I'm going to talk about some of the megatrends that are going on in the industry and how that relates to this Industry 4.0 that we find ourselves in. And once we have this landscape, I'll highlight some very specific use cases that could be a part of the semiconductor industry as we move towards a data-driven future. So let's start with the past. If we were to summarize test in one sentence, we'd probably come up with something like, we test to collect data. And we've been able to do some amazing things with that data. We automate our entire test cells. We have yield learning. We gather all sorts of statistical information on our automated process. But we're not able to truly realize the full potential of the data. And that's primarily because the data is siloed. It's behind different customer clouds. The data is often in completely incompatible formats. And we don't have the tools to easily reflect those changes and move data to where it's needed. So that's really hindered us from taking advantage of all that this Industry 4.0 has to offer. However, the future, what we believe is going to start happening is we'll start to see all of these data lakes that are currently siloed tied together. And it'll probably be tied together with some sort of super data highway. And Stacy Ajuri from TI, she gave us a glimpse of what one such possibility called RITDB. But whatever the case may be, once we tie all of these together, and then we can apply machine learning on top of it, we'll start to have all these new insights and new intelligence that frankly we just haven't had access to before. And that's going to change everything. So instead of the past where we tested to collect data, the data itself will actually tell us how to test. So instead of testing to collect data, the data will tell us where to test, how to test, when to test, and what tests are needed. And we'll start to be able to answer very important questions that we've had for quite some time, but we just weren't able to answer them. So questions like, how do I optimize my entire test flow to get a specific yield with a specific cost? How should I distribute my tests across that test flow? And what would happen if I move this test from insertion A to insertion B? How does that affect my cost, my yield, my coverage? What if I add test? What kind of yield improvement do I get? Or what if I remove this test? What does that do to my coverage? So these are the sorts of questions that we'll start to be able to answer in this data-driven industry. So let's start with big data. You've probably seen a slide like this before, and you hear someone say, like, in the past 2 years, we've generated more data than in all of human history. And that's a mouthful, and that means there's a lot of data. And it's estimated that in the next few years, we'll be generating 44 exabytes of data per day. So I had to look up what an exabyte is, but I don't know who created that number or where it came from, but obviously whoever did it hasn't read Hitchhiker's Guide to the Galaxy. Because if they had, that number would be 42. So how much data is that? Well, if you convert that data into DVDs and you stack it, that's 5 billion DVDs per day. And since we're in Washington, D.C., I converted that to the number of Washington monuments. That's 36,720 Washington monuments. It would reach out into outer space. So the point is, we don't really have a good reference. We need something global to wrap our heads around how much data this is. So, wrap our heads around it. Let's wrap it around the Earth. It would take 7 days for us to complete the circle around the Earth with the DVDs. So maybe we should start calling the amount of data that we're generating in terms of Earth bytes. So we generate an Earth byte of data every week. In any case, I think we all are in agreement, it's a nearly infinite amount of data when you think about it. And that data, as you can see from the graph, is the kind of fuel that's driving these megatrends. Megatrends such as 5G and IoT and cloud computing and artificial intelligence. And all of those trends, they actually feed off of each other. So as one of them grows, it pushes the others to grow. So you have this snowball effect. And the snowball shows only signs of increasing in velocity. So we've reached It's one of the other visionaries 2 days ago, he was talking about this push-pull. And we're in that pool where now we need to start taking advantage of all this new technology that's available, like big data and machine learning, analyzing that. So it's interesting if you think about where does all this data come from? Turns out half of the data comes from us, just walking around in our smartphones. Shouldn't be too surprising because smartphones are nothing less than supercomputers. And supercomputers have a way of generating tons of data. So that's about half of that data. Well, about the other half comes from this IoT, the Internet of Things. And the Internet of Things, you can sum that up as billions and billions of sensors connected all around the world, all the time, everywhere, transmitting wirelessly across our 5G networks. So that's a lot of data. And that data has to go somewhere, which is into these cloud farms. We have these cloud farms and cloud servers all over the globe. But the data keeps growing. The applications keep growing. The 5G networks keep growing, and they all feed upon each other. So we're in this age of this industry era 4.0. So now that we have that as a landscape, let's do the vision stuff. Let's put and map 5 specific use cases that we may see in the semiconductor industry in the next several years. And I'll briefly describe them here, and then we'll go into detail of each one of them. So the first one, understanding customer benefits. With all of that data and all of it tied together and using the machine learning techniques to create new business intelligence and insights, we're going to understand our customers a lot better. And we're going to understand our markets and our trends a lot better. So how do we do this right now? You've got experts in various companies, and they spend their entire lives looking through financials and listening to quarterly calls. And they're the gurus. They use their crystal balls to predict where the market is going, where the inflection points are. And then they advise the R&D organizations to place bets. And it's gambling. It's a bet because nobody knows. And the confidence levels, if you ask, who knows? It just depends. I would say we're as often incorrect as we are correct. And this has an adverse effect on our industry because now we're all risk averse. We don't want to spend the money because it's just as likely we're going to be wrong as we are right. But imagine that that's going to change and our insights are going to give us high confidence that our investments are going to pay off. That's going to just further accelerate this industry. So this is a very good time to be in the semiconductor industry. The second one, decision making. So data is power, and with that data, we'll be able to much more effectively make decisions, and we can make these decisions near real time. And we can use that data strategically and operationally, and I'll talk about a very specific use case. The third, improving customer value proposition. So what is that? Well, we deliver testers, but we want to deliver smarter products, smarter capabilities, and smarter services. So we want to take this data, apply machine learning, integrate it into our products, and improve the value to our customers. And that will in turn allow our customers to improve their values. And I'll talk about a very specific use case. One of my favorites, and according to my CO, it should be the favorite, monetization. So data as an asset. Well, data is an asset. Recently in the European Union, they passed the law that it is forbidden to use your data without explicit permission from yourself. So they've recognized that your data is highly valuable, and if somebody wants to use it, they have to pay you for it. They have to compensate you for it. So this will drive new businesses and services that we haven't been able to achieve yet. And I'll talk about one very specific to Advantest. And the last one, automating key business processes. So I'm sure almost every one of you in this room has experienced the hurry up and wait in our industry. We have these highly automated test insertions, test processes, whatever you want to call them. They're highly efficient and highly automated. But in between, not so much. Our ability to develop automation in these in-between areas is going to be one of the additional advantages to drive efficiencies across operations. Okay, so let's get into it. The first one, understanding customers better. So it's a bit complicated. It's all about test challenges. Imagine that we have access to all of this data. We understand these trends much, much better. We have insights into our customers much, much better. Well, we're going to understand our customers' drive to and beyond the 5 nanometer process and how post-silicon, wafer, package, system level test, burn-in, how they all play a part, and we need to orchestrate them in order to meet the requirements that our customers need. And understanding the entire supply chain's cost challenges. So we're really good at understanding our direct customers' cost challenges. Where we're not so good is understanding our customers' customers, or our customer's customer's customer. So all the derivative of those, we have very limited knowledge and experience with. But that's going to change, and we'll be able to provide products and services that help that entire supply chain. Understanding how quality improvements drive automotive. So Andreas, he's setting me up really nice with that. So with autonomous vehicles connecting into our 5G networks, well, our smartphones are hosted on the 5G networks. All the IoT devices are hosted on the 5G networks. So it's only going to be natural that the quality requirements from automotive, which are more stringent, are going to push into those other customer spaces. And how are we going to deal with that? Well, we're going to deal with that by utilizing all of this data. We're going to be able to make better decisions, how to balance and optimize the test flow in order to push those quality requirements onto those segments without adversely affecting the cost. And last but not least, understanding 5G. So it's not just another G. 3G to 4G, if you compare the innovation going from 3 to 4 versus what we have to do to go from 4 to 5, it's a step function. What we did from 3 to 4 was an incremental innovation versus what we're having to do to go from 4 to 5. And that's primarily driven by these three: phased arrays, over-the-air, and millimeter wave. All three of these are mature technologies in our cousin industry in the mil-aerospace. They've had that for years, but not at the cost points that we need, and certainly not at the volume scales that we require. So again, we're going to have to take this data and these insights, and we're going to have to leverage what our cousin industries have done, innovate on that technology to bring the cost down, and then deploy that at scale. Now, sounds like it's hard, and it is, but we already have done this. We did it in the late 90s when we first put RF onto our ATE testers. People said, oh, it's too expensive, it can't be done, you're going to go out of business, and in 2 years, we had production solutions. And look where we are now. So we did it before, we'll do it again. The second use case is decision making. So imagine in the near future that you will be able, with reasonable accuracy, with just a few measurements early in the process, you'll be able to predict the yield of the wafer. Imagine how that's going to completely change volume planning or supply chain management. So right now we have these huge peaks and valleys when yields suddenly drop off, and our supply chain is forced to absorb that. It's very costly and it's very inefficient. But imagine if you had a priori knowledge that your yield was going to drop in a month. You don't know why. You just know it's going to happen. What would you do? Well, obviously, you'd go ahead and start additional wafers. And how would that affect the supply chain? Well, the supply chain would maybe feel it as a ripple. So instead of these huge spikes, it would all get averaged out. And that's going to help our entire industry run much smoother, much more efficiently. And it might sound like magic, but this has already been demonstrated by the fabs. This has already been proven. And we know that it works because next generation devices are the children of the previous generation. So they share an enormous amount of DNA. And just like the child and the parent shares DNA, if you have measured the parent across this entire test flow and collected all of this data and have all this understanding of the parent, when that child is first born with just a few measurements, you can make very accurate predictions on how that child will perform or how that child will yield. Terms like overcapacity and underutilization as problems, they may start to disappear. The third use case, improving the customer value proposition. So we talked about smarter products, smarter services, smarter capabilities. Well, in the oil and gas industry, they're already deploying this into their production. So it's proven technology, they've proven the models, they've proven the ROI that they get from it, and they're deploying them into their production facilities. What are we going to do? We're going to leverage that knowledge, use our fleet of testers. We have thousands of testers full of data, run that data through those models, and we can do the same thing. And we could perhaps offer that as a service or as a product to our customers. And you can see all of the benefits that the customer chain or the supply chain would have. You'd have smart replacement, decreased planned maintenance. You would have a situation where testers don't go down right in the middle of a very important high-volume run. The asset would always be available. So it's interesting. So if any of you follow Amazon, Amazon's working on this software, this predictive software. And what it does is it predicts what you're about to buy. And they go ahead and they ship it to you before you even buy it. So you'll get out of bed, open your front door, and there'll be a box from Amazon. And you'll open it up and go, wow, I didn't know I needed this. But I'm going to keep it. So maybe in the near future, well, and you'll say, thank you, Amazon. But maybe in the near future, our field service engineers will show up at your production door with a module in hand before you even know you needed it. And we'll replace that module, and the system will never go down. And you'll say, thank you, Advantest. So one of my favorites, this monetization, Again, data as an asset, and we said data is an asset. And how can we use that data to drive new businesses and new services? So perhaps you've heard the term in the Industry 4.0 called digital twin. So digital twin is where you create a digital replica or a digital ghost of a tool or an asset, and you host it in the cloud. And then we could offer that as a service or as a product. We could lease it. We could sell it to customers that want to run their data through these virtual insertions. So we could have multiples of these. We could have a wafer virtual insertion, a package virtual insertion, a system level test virtual insertion. And the customers could actually run their data through all of these insertions and get a very good predictive understanding of how it's going to perform through each of those stages. What's it going to cost? What's it going to yield? If you knew before first silicon that you were going to yield 18%, is that valuable to you or not? I think so. So other benefits that could come from this are a completely optimized test flow. You as the customer could designate what your target yield is, what your target cost is. And the flow could be completely optimized to give you that target. And think about that because that's important to you depending on where you are in your product life cycle. If you're brand new and this is a brand new product, all you care about is yield. You want to get product into your customer's hands. So you would perhaps optimize the entire system for yield. But if this is later and it's a very mature product or it's an aging product and now all of the competitors have caught up to you and you're under extreme cost pressure, then maybe you would like to re-optimize the entire test flow for cost. That's possible with this type of service. And the fifth and the last is automating and improving business operations. So we talked about hurry up and wait, and automating some of those processes. So I think Mike Campbell gave a visionary talk, and he talked about how he has 300 engineers, and they're bogged down in the tedious minutia of this manual scripting and converting and all of these things that have nothing to do with engineering. And he wants to offload that and upskill those engineers so they can work on truly test engineering tasks or product engineering tasks and not have to deal with all this underlying minutia. And if you haven't seen it, Professor Lee Si Wang has some software. He's demoed it a couple of years here at ITC. It's called AYA, Intelligent Engineering Assistant. And what it does is it uses machine learning to look at a bunch of wafer data and give you insights into that data, suggestions, recommendations, things to go look at, things that you might be concerned about. So applying that logic here, this situation or this scenario that's represented here on the slide, we're looking at perhaps a new RF product, and it's being brought into production. It needs to ramp on the new wave scale RF that we have. And if you haven't ramped something before, you know that it's plagued with problems and issues. It's the first time that you're putting everything together, the load board, the socket, the chip, the test program, the handler. All of these things, it's the first time it's being put together. And it takes a tremendous amount of effort from the engineers to get that into production. If you're lucky, it takes several days, but it can take several weeks. So what if we had an intelligent assistant, and this would be the proverbial Jarvis that's helping or assisting Iron Man. So this would be an assistant that is specialized in a specific skill set. It could be RF, it could be high speed. And this intelligent assistant is monitoring the entire scenario. It's looking at the inputs, it's looking at the outputs, it's looking at the interactions between the engineers and the test system itself. And it's not solving the problem. It's making suggestions of where to look. In this case, it's suggesting there perhaps is a ground issue on pin 14, and the confidence interval is 63%. So you as the engineer could go off and check that versus having to just search through all the possibilities. And you could imagine that if this were available on our fleet of testers, which there are thousands of them, how fast, with reinforcement learning, these assistants could rise to perhaps almost an expert level. So all of that minutia that we have to deal with right now as test engineers and product engineers, that could be absorbed by these intelligent agents. And we could offer that as a product or as a service. And even third parties may come in and do that, where they build their own for some special hardware that they've developed. So my last slide, in summary, Advantest has a 10-year grand design vision. And in this grand design vision, you can see in the middle is our core. That's where we came from. That's our final test, our wafer test. And we're working to go left and to go right. So I guess I should go left this way. So to go left, we're working with the EDA tool vendors, and we're linking those tools together to provide extended capabilities in the go left strategy. In our go right strategy, we've got our newly acquired Advantest test solutions, which build system-level test and burn-in test. And we're mapping all of these together and overlaying it and connecting it with cloud, AI, and data analytics. So you can see that all of the use cases that we've described here actually fall into this strategy. So it could be that in the next several years, we may start to see some of those in reality. So with that, I say thank you.